In this video, attribute selection measures will be covered. Selection measure is a heuristic for selecting the splitting criterion that best separates a given data partition D of class labeled training tuples into individual classes. If we are to split D into smaller partitions according to the outcomes of the splitting criterion, ideally each partition would be true. That is, all the tuples that fall into a given partition would belong to the same class. Selection measures are also known as splitting rules because they determine how the tuples at a given node are to be split. Three popular attribute selection measures. Number one, information gain. Second, gain ratio. The third one is Gini. Information needed to classify a tuple D is given by info of D equals to the sum of I equals to 1 to m pi log of pi. How much more information would we still need in order to arrive at an exact classification? The amount is measured by info of attribute of D, sum of j equals to 1 to v, the d of j divided by d multiplied by the info of dj. The term dj divided by d acts as a weight of the jth partition. Info a d is the expected information required to classify a tuple from database dataset D based on the partitioning by attribute A. The smaller the expected information required, the greater the purity of the partitions. Information gain is defined as a difference between the original information requirement. On the screen presents a training set D. Shop customer database and the data sets are shown in the previous screen. In this example, each attribute is discrete valued. Continuous valued attribute have been generalized. The class label attribute Wise computer has two different values, namely yes or no. Therefore, there are two different classes, that is m equals to 2. Let class C1 correspond to yes and C2 correspond to no. There are 9 tuples of class yes and 5 tuples of class no. A root node n is created for the tuples in dataset D. To find the splitting criterion for these tuples, we must compute the information gain of each attribute. We can use the following equation to compute the expected information needed to classify a tuple in dataset D. Info of D equals to minus 9 by 14 log of 9 by 14 minus 5 by 14 log of 5 by 14 equals to 0.940 bits. Next, we can compute the expected information requirement for each attribute. Let's start with attribute A, age. Look at the distribution of yes and no tuples for each category of age. For the age category youth, there are 2 yes tuples and 3 no tuples. For category middle age, there are 4 yes tuples and 0 no tuples. For the category senior, there are 3 yes tuples and 2 no tuples. The expected information needed to classify a tuple in dataset D if the tuples are partitioned according to the age. Then info of age D that has been given in the screen. The result is 0.694. So gain of age equals to info of D minus info of age of in the data set, that is equals to 0.940 minus 0.694 equal to 0.246. Then likewise we compute the gain for income and credit rating also. So income is 0.029, for student rating equals to 0.151 and credit rating equals to 0.048. Age is the highest information gain among the attributes. It is selected as a splitting attribute. As shown on the screen, very easily we can understand the tuples falling into the partition for age equals to middle age all belong to the same class. Because they all belong to the class yes, a leaf should therefore be created at the end of this branch and labeled with yes. Information gain of attribute, a split point for A, where the split point is a threshold on A. First, sort the values of A in increasing order. The midpoint between each pair of adjacent values is considered as a possible split point, AA plus AA plus 1 divided by. On day 15, The new data tuple is given with the values, outlook values rain, humidity value is high, and wind is weak. So accordingly, we are going to predict whether the John is going to play the tennis or not on day 15. As shown in the diagram on the screen, 9 S category and totally 5 no categories available. Then we are going to split, and then based on the outlook is overcast mean 4 records are given. So in the 4 record, all are, it is pure because all are belong to the S category. There is no 0 category. Left hand side is a sunny, outlook is sunny means the 2 S category and 3 no category. There is no splitting further in the from this level. Right hand side rain, then we have 5 no categories available. In this case, where based on the rain, then 3 S category and 2 no tuples are available. In this record, the yes and no are separately shown on the screen. Very easily we can understand. In this diagram, how many records are comes under the yes and how many records are no category shown. All yes categories are shown in green color, no category is shown on red color. So now we are going to predict on day 15 data values. The rain, outlook is rain, humidity is high and wind speed is very weak. Then we can predict that yes, he is going to play the tennis. Gain ratio, it prefers to select attributes having a large number of values. SEEP 4.5 is a successor of ID3, uses an extension to information gain known as gain ratio. It applies a kind of normalization to information gain using split information value defined analogously with the info of DS, split information of attribute on dataset D, then sum of j equals to 1 to v dj by d multiplied by the log of dj by d. Gain ratio differs from information gain, which measures the information with respect to the classification that is required based on same partitioning. Gain ratio is defined as gain ratio of A equals to gain of A divided by split information of A. The computation of gain ratio for the attribute income. A test on income splits the data into 3 partitions, namely low, medium, and high, containing 4, 6, and 4 tuples, respectively. To compute the gain ratio of income, it's given and in the following equation, split information of A of D. A is an income, D is a data set equals to minus 4 by 14 into log of 4 by 14 minus 6 by 14 into log of 6 by 14 minus 4 by 14 into log of 4 by 14. If we calculate gain of income equals to 0.029. Gain ratio of income equal to 0.029 divided by 0.926 equal to 0.031. The Gini index is used in CART, where PA is the probability that a tuple in D belongs to class CI and is estimated by the CID divided by D. The sum is computed over the M number of classes. Gini index considers a binary split for each attribute, where A is a discrete value attribute having V distinct classes A1, A2 up to AV occurring in dataset D. Determine the best binary split on A. We examine all of the possible subsets that can be formed using known values of A. If A has V possible values, then there are 2V possible subsets. Exclude the power set like low, medium, high, and the empty also, they do not represent a split. 2 to the power of A minus 2 possible ways to form 2 partitions of data for dataset D based on a binary split A. As per the following equation, we can find the Gini index. For a discrete valued attribute, a subset that gives a minimum Gini index for the attribute is selected as its splitting subset. The reduction in impurity that would be incurred by a binary split on a discrete or continuous valued attribute A is Gini of A equals to Gini of D minus Gini attribute of D. The attribute that maximizes the reduction in impurity is selected as a splitting attribute. Reduction of a decision tree using Gini index. Let the dataset D be the training data where there are 9 tuples belonging to the class buying computer equals to yes and the remaining 5 tuples belong to the buying computer equals to no. A root node n is created for the tuples in dataset D. The equation for Gini index to compute the impurity of the dataset is given. Gini of D equals to 0.459. Then start with the attribute income and consider each of the possible splitting subsets. Consider the subset low comma medium. This will result in 10 tuples in partition D1, satisfying the condition income is an element of low comma medium. The remaining 4 tuples of D can be assigned to partition D2. Then if you calculate the Gini of income is an element of high in the dataset D. Gini index values for splits on the remaining subsets are given: low, high and medium 0.315, medium, high and low 0.30, 0.300. So Gini index of 0.375 for student equals to 0.367, credit rating equal to 0.429. The attribute income and splitting subset medium, high, therefore give the minimum Gini index overall with the reduction in impurity of 0.459 minus 0.300 equals to 0.159. The binary split income is an element of medium, high results in the maximum reduction in impurity of the tuples in dataset D and is returned as a splitting criteria.